So this angle here is going in a positive way because it's going counterclockwise, and it goes around 2 full rotations, so that gives you 720. And then it goes this little bit more, and we know this part here is 75 and the whole thing is 90, so this is another 15, so that's 735 degrees. For number 2, this goes around in a counterclockwise also, but it goes around three full times. So that's 360 times 3. And that's 10,080, but it doesn't quite get all the way around. It's 20 degrees short here before we go for a full 3. So it's 1,080 minus 20, because it didn't go all the way around. It's 1,060 degrees. And here we're going to draw the angle. We're going negative, so we're going clockwise. And we know that to go all the way to here is 90 degrees, and we have to go a little bit further to get to 100. So it would be right here like that. It would be negative 100. 190 would be going all the way through 180 and a little bit more there. It needs to go 10 more in that direction, so that would be negative 190. So here we add 360 until we get a positive angle, and the positive angle is 245. So this is 180, and 245 is somewhere in here. And that's going to be 65 degrees from the x-axis. So the reference angle, remember, the reference angle can never be more than 90 degrees. So this one here, when you get it out of the woods, is 155, and 155 is up here. And this is 180, and it's 25 degrees from the x-axis. So you just subtract the 2 and you get 25 degrees as the reference. So when you're converting degrees to radians, it's 540 times pi over 180. And I just put that in the calculator, 540 over 180, and I get 3, and you gunk a pi. You don't put the pi in the calculator. Negative 315 over 180 with a pi there, and that turns into negative 7 pi over 4. So this fraction turns into negative 7/4, and you just gunk the pi. Now when you're doing radians to degrees, you take the radians and you multiply it by 180 over pi, and the pi's bite the dust, and then you just do the math. You multiply 127 times 180 and then divide that by 36, and you get 635 degrees. And pi over 4 is on your unit circle, and that's 45 degrees, but if you want to do it out, it's pi over 4 and 180 over pi. The pi's bite the dust, and 180 divided by 4 is 45 degrees. If you get 630 degrees out of the woods, you get 270. So they want the cosecant of 270, which is the reciprocal of the sine of 270. The sine of 270 is negative 1/2, and the reciprocal of negative 1/2 is negative 1 is negative 1. So the answer is negative 1. The sine of 270 is negative 1, and the reciprocal of negative 1 is negative 1. And this is on your unit circle. This is also negative 90 is 270 also, so it's the cosine of 270, and that is 0. So this one, I like to it's in the third quadrant. You go minus 3, minus 4. And when you figure out the hypotenuse, it's a 5. Theta always comes out of the center. And they want the cosecant of theta, which is the reciprocal of the sine. So if the sine is opposite over hypotenuse, it's going to be hypotenuse over opposite. And I always put the negative on top, so there's your answer. Here, we're going to go left 4, which is a negative, and up 2 root 5. And they want the secant, so we do need the hypotenuse. So it's 2 root 5 squared plus negative 4 squared, but you're going to put that in parentheses. And that's 20 plus 16, which is 36. So this side here is a 6. And the secant is going to be adjacent. It's the reciprocal of cosine. So cosine's adjacent over hypotenuse, so it's going to be hypotenuse over adjacent, which is -3/2. All right, so number 15, if it says that the secant is -5/4, it's where cosine is negative. Students take calculus. So the sine is positive, so it has to be here. And the cosine is negative, so it has to be there because the cosine is negative here and here, but it has to be where the sine is positive. So we're going to draw it in the second quadrant. And if the secant is 5/4, the cosine is 4/5. So this is 4 and 5, and that's 4 there. We know this is a 3. And they want you to find the exact value of the trigonometric ratio. So on the final, I'm only asking you to find one of these, even though they find all of them. So we're just going to find the cotangent of theta. Well, cotangent of theta is the reciprocal of TOA, so it's adjacent over opposite, and the adjacent is -4, and the opposite is 3. So that is the only one you're going to have to do. For cosine is negative and sine is positive, it's going to still be in that same one. And if the cosine's -21/29, and they want you to find cotangent, we're going to have to find this side right here. So we have x squared plus -21 squared equals 29 squared. So when we find x, it's going to be 20 when we do Pythagorean theorem. So now we want to find the cotangent of theta, and that's adjacent, which is -21 over opposite, which is 20. So that would be your cotangent. If you want to find all 6 to practice, that's fine too. So the cosine's positive, the sine is positive, that's in the first quadrant. And the sine is 7/25. And they want the cotangent, so we're going to have to find this guy right here. So x squared plus 7 squared equals 25 squared. Let's find x. So this is 24. And it's going to be adjacent, which is 24 over opposite. And we know it's always positive. So the cotangent of theta is that.